More white storks, more human births. The correlation was real. The obvious cause was absurd. Yet research headlines, business dashboards, and market commentary make the same move. A correct pattern is treated as if it identified its own cause. It cannot. Three things can break that story. A hidden variable may move both lines, the causal arrow may point backward, or the visible pattern may be the winner of an invisible search. We can turn those three traps into 5 questions. What is the mechanism? What happened first? What could move both variables? How many analyses were possible, and does the result survive new evidence? The opening chart came from a real analysis of 17 European countries. It found a correlation of 0.62 between breeding pairs of white storks and annual human births. The p-value was 0.008. The calculations looked serious. The causal story did not. Storks do not deliver babies. But the mistake matters because the data can be collected correctly, the calculation can be correct, and the explanation can still exceed the evidence. Start with the narrow claim the data supports. In that dataset, countries with more stork pairs also tended to report more births. That is evidence of association. It tells us that two quantities varied together. Association is useful. It can improve prediction, flag an anomaly, or tell us where to investigate. An umbrella on the pavement is evidence that it may be raining, even though opening umbrellas does not make rain fall. That difference changes the action that follows. A stable correlation may help us forecast an outcome without telling us what to change. Many judgment failures begin when a useful predictor is quietly promoted into a lever. A causal claim asks for more. It says that changing one thing would change another because of a plausible process or because a credible research design has ruled out important rivals. That is a claim about intervention, not just observation. The same table can support several stories. Storks could cause births. Births could somehow attract storks. A third factor could increase both, or the pattern could depend on the country's period or analysis choices. The columns do not draw an arrow between themselves. The arrow comes from assumptions, design, and judgment. This is also why a p-value of 0.008 does not mean there is a 99.2% chance that the stork explanation is true. Under the specified no association model and its assumptions, it describes how unusual a result at least this extreme would be. The American Statistical Association explicitly warns that a p-value is not the probability that a hypothesis is true. So split every confident chart into 2 sentences. First, what was observed? Second, what cause is being proposed? Then test the distance between them. Robert Matthews, who published the stork analysis, offered land area as one candidate confounder. Larger countries can contain more habitat for storks. They can also contain more people and therefore more births. Now the picture has 3 nodes, not 2. Land area points toward stork pairs. Land area also points toward births. Once that third node appears, a direct arrow from storks to babies is no longer required to explain the pattern. Land area does not have to be the only explanation. It only has to show that the original story did not earn exclusivity. One credible rival reopens the case. Imagine a dataset in which larger fires are attended by more fire trucks and also produce more damage. A 2-column chart could make the trucks look harmful. Add a third node called severity. Severe fires can cause more damage and cause the department to send more trucks. The number of trucks may still help predict damage because it carries information about severity, but reducing trucks would not remove the severity. It could make the outcome worse. This is the first practical distinction. A variable can be a useful signal without being a useful lever. The same logic can appear in a business dashboard. Suppose customer complaints rise before cancellations. Complaints may contribute to cancellation, but both may also reveal a deeper product failure. Deleting the complaint channel would remove the signal, not fix the product. Before accepting X causes Y, draw one more node. Ask what Z could push both X and Y. Company size, age, geography, demand, risk tolerance, project complexity, or selection into the sample. You may not find the right Z immediately. The point is to stop a 2-column chart from choosing a single explanation by default. This is difficult because dashboards display what was measured, not everything that mattered. The missing condition has no line, no label, and sometimes no field in the dataset. A clean visual can therefore create confidence by hiding the variable that would make the story less clean. Ask not only what the chart contains, but what the data-generating situation left outside it. The second trap is direction. Rain and umbrellas rise together on a wet day. Umbrellas do not cause rain. Rain causes umbrellas to appear. The correlation is real. The proposed arrow is backward. Real systems hide that reversal inside plausible stories. Imagine a sales dashboard showing that teams with more internal meetings tend to close fewer deals. A manager concludes that meetings destroy productivity. The mechanism sounds reasonable. Meetings consume time that could be spent with customers. But the arrow may also run the other way. A weak pipeline creates anxiety. Anxiety produces forecast reviews, coaching sessions, and more meetings. Poor results can cause meeting volume to rise. Both directions may operate at once. Extra meetings reduce selling time. Weaker results trigger more reviews, and a feedback loop forms. A chart with one line for meetings and one for sales cannot tell us which direction dominates. A snapshot makes this especially hard. If the dashboard averages an entire quarter, the sequence disappears. Meetings and weak sales occupy the same row, even if one rose several weeks before the other. Before debating the story, rebuild the timeline at the pace the mechanism is supposed to operate. Time order is the first check. Put timestamps on the proposed arrow. Did meeting hours rise before deal volume declined or after? Does the delay match the claimed process? Sequence can eliminate impossible stories, but it cannot certify the last story standing. If X happens before Y, both may still be responding to an earlier Z. An alarm sounds before people leave a building, but the alarm is not what made the building dangerous. A credible cause needs the right direction. It also needs either a plausible process or a design that changes the proposed cause while blocking serious rivals. So question 2 is not merely, did these lines move together? It is, which arrow fits the timeline and what observation would distinguish it from the reverse arrow? The third trap sits outside the finish chart. An analyst rarely has only one decision available. Which outcome counts as success? Which month begins the comparison? Should unusual observations be excluded? Should the data be divided by region or customer type? Which controls belong in the model? When should data collection stop? Each choice may be defensible. Together, they create many paths through the same data. Methodologists call this researcher degrees of freedom. A related idea is the garden of forking paths. Even when only one analysis is reported and nobody is consciously cheating, the selected path may have depended on what the data happened to show. Picture an analyst with several outcomes, date ranges, customer groups, and exclusion rules. Most combinations show nothing stable. One combination produces a clean relationship. The presentation shows that chart, a confident headline, and none of the paths that failed. The chart may be calculated perfectly, but its apparent surprise is larger than it should be because the search is invisible. This does not make exploration illegitimate. Exploration is how useful patterns are discovered. The mistake is presenting a discovered pattern as if it had been specified and tested independently from the beginning. The honest sequence has 2 stages. Use existing data to generate a hypothesis, then test it with a new period, an independent sample, or a pre-specified analysis that cannot move after the result appears. The distinction is not between creative analysis and rigid analysis. It is between discovery and confirmation. During discovery, follow surprising paths and label the result as a lead. During confirmation, lock the main outcome, comparison, and exclusion rules before seeing the answer. The same dataset cannot provide the surprise and then act as a fully independent test of that surprise. So ask about the search space. Was this the original outcome? How many groups and time windows were available? Which exclusions changed after the chart was seen? Which reasonable analyses led somewhere else? The more paths that were available, the more the winning pattern needs a fresh test. Now return to the sales dashboard. The observation is simple. Teams with more internal meetings close fewer deals. The proposed action is also simple. Cut meetings to increase revenue. The story may be right. Here is what it must survive. First mechanism. If meetings displace selling time, the effect should be strongest when they occur during prime customer hours. Cutting a duplicated reporting meeting should matter more than cutting a short coordination meeting that prevents rework. A useful causal story predicts details beyond the original chart. Second, time. Did meeting hours rise before sales declined, or did managers schedule reviews after the pipeline had already weakened? Weekly averages may hide the sequence. A lag timeline can separate the 2 arrows. Third, rival causes. Harder territories may require more coordination and produce fewer wins. A new product may create training meetings while customers remain uncertain. Complex accounts may involve more specialists and longer sales cycles. These rivals do not prove meetings are harmless. They show what the direct story must beat. Fourth, search space. Was meeting time the original metric, or one of many? Was performance measured as deal count, revenue, margin, conversion rate, or pipeline value? Were teams, quarters, or unusual weeks selected after the result appeared? Fifth, new evidence pre-specify the measure and the time window. Compare similar teams. Test a limited change, such as protected selling blocks, without simultaneously changing compensation, territory, product, and staffing. Then check the mechanism. Did customer conversations rise, and did outcomes improve after a plausible delay? Repeat in another period. Before this audit, the manager's decision might have been a company-wide meeting ban. After the audit, the better decision is narrower. Keep the meetings that coordinate complex accounts. Pilot protected selling blocks with comparable teams. Decide in advance which customer activity and revenue measures will count. Watch whether the predicted intermediate step, more customer time, actually changes before judging the final result. If customer time rises but sales do not, the original mechanism is weaker than it sounded. If neither customer time nor sales changes, meeting volume may have been mostly a signal of difficult conditions. If the predicted sequence repeats across teams and periods, confidence in the causal story rises. The questions have not produced certainty. They have produced a better next action and evidence that can discriminate between rival stories. This test does not demand perfect certainty before anyone acts. It separates a useful lead from a conclusion that has earned confidence. A pattern can justify investigation. A plausible explanation can justify a cautious test. A cause becomes more credible when its direction, mechanism, rivals, and predictions survive contact with new evidence. The stork chart was not fabricated. The calculation was not the joke. The mistake was asking an association to identify its own cause. Keep 3 points in mind. Correlation is evidence of a pattern, and patterns are useful. The pattern alone cannot tell you whether a hidden variable, a reversed arrow, or an invisible search produced the story attached to it. Confidence should rise when the explanation survives serious rivals and predicts what appears in new evidence. The judgment principle is simple. A pattern tells you what moved together. A cause must explain why. What chart have you seen recently that might have another cause?